So first of all, thank you for sticking through. It's a long afternoon and I'm part of it, so I'll try to make this interesting. This is about software. This may be relevant directly for some of you who create software. I hope it's relevant for those of you who use software. And if it's not relevant, at least I'll try to make it interesting. I'll do my best. Fantastic. So, don't need the agenda. Let's go through a little bit of recent history. In 2017, Equifax had a problem with deploying, or rather fixing, some open source. And that resulted in an enormous hack of 136 million credit card records. And they were subsequently fined $700 million, okay, as a punitive action. So that was some time ago. Then in 2020, the SolarWinds hack occurred. Now this was a supply chain hack where SolarWinds distributes network management software to multiple organizations, and their application was infected by malware within their development lifecycle. And we don't know a lot about it, but we do know that about 18,000 organizations downloaded the impacted software and deployed it. Again, we will never find out how many companies were actually affected because most of the US government, the EU, UK, and other organizations, Microsoft, and many other companies were actually potentially affected. So we'll probably never really hear about that one. And then, of course, Log4j, which was December 2021, and that's an open source issue. It's a zero-day exploit which was discovered by accident. And essentially, this is in a common piece of Java framework for logging application, for creating application logs. And what we do know is that at peak, in fact, all the way up to today, there are more than 10 million exploit attempts on Log4j every hour. There's potentially 100 million applications which are affected by it, we think. This is an enormous issue, okay? So clearly these have focused the mind, and really the sequence here is that we started with one company, one issue, we went to one company to 18,000 clients who were affected, and then one issue, and literally hundreds of millions of applications which were affected. And this led, essentially, this sequence led to the executive order from the White House, which is the improving the nation's cybersecurity. And it's useful to reflect just for a moment, what is that? What exactly did Biden want to do? Well, he asked multiple agencies to look into how to make software more secure. And their vision is this rather complicated diagram. It starts on the left here in the plan and moves around of adopting software. I've highlighted some interesting points in red. Here we've got third-party software, which we're onboarding. Here we've got the components we're building. And on the right-hand side, we'd have this idea of telling people in a detailed way what we're actually distributing. And this is called an SBOM, a software bill of materials, okay? This has been around for a very long time, but the executive order brought it back into focus, okay? So you've probably heard about it, software bill of materials, or other types of bills of materials. There are other ones as well. And this is an idea to actually improve that. Now, on the tail of that, we've also got the Cyber Resilience Act. This is the EU regulation covering all software. And what you can see here is that they're close to actually implementing this. Probably by the end of the year or early next year, there will be the Cyber Resilience Act implemented. It takes some time to actually apply, but essentially what they're going to do is categorize all software into these three verticals, different levels of category, with class 1 and class 2 at higher levels, but essentially all software that any supplier distributes or hosts will have to comply with these regulations in order to operate in the EU. And again, SBOM is mandated. That's part of how that's going to work. The UK, frankly, is just following along. Probably the right thing to do at the moment. We don't want to break any new ground until we know what everyone else is doing. But essentially, they're just tracking along behind to try and work out what to do. So what exactly is the problem here? These are supply chain risks, software supply chain risks. And essentially, there are a numerous number of them. I mean, you've heard about some of them, but let's just talk about it. Zero-day exploits, public notified vulnerabilities. There's a thing about license risk. We can talk about that as well. Malware, information leakage. And I don't have time or interest, really, to go through the literally hundreds of different types of supply chain risk. And we'll delve into that a little bit in a moment, but before we do that, what are we talking about when we say software, when we talk about supply chain? Now, this is a report from Synopys, the company I work for, done every year, and essentially we assess software which we look at for other organizations. So every year we do assessments, and there are about 1,800 assessments in the year up to 2023. And what we can see here is that a large proportion of that software, in fact about 76% of all software, is open source. So in fact, the supply chain issue is mainly open source and some proprietary software, the bits we write, okay? Now, it's interesting also to notice that in that assessment, more than half, or nearly half, of all of that software was vulnerable to critical risks. And by the way, we're talking about production-released software. We're not talking about, in development. And one other issue, I mean, remember Log4j, that's nearly coming up 2 years ago now. We should know about this. This should have been fixed. And we see that out of the proportion of code, which was Java-based, about 11% has not yet been patched for the critical remote code execution vulnerabilities that are inside Log4j, which is, again, totally unacceptable. I mean, it's coming up 2 years since we found out about that. So let's just do a thought experiment for a moment. So allow your minds to wander for a moment. We're actually going to develop, or pretend to develop an application. Okay, so you're all developers for the day. I know, it's exciting, isn't it? And what we're going to do is we're actually going to develop an application to integrate Slack and Instagram. Now, don't ask me why, it's just an idea. But to do that, we're going to choose a common framework, which is JavaScript, and we're going to develop an application to use some dependencies, okay? And there are 8 dependencies we're going to use, the sort of thing we might do. So 8 things that we need from the public resources in order to get this working, okay? Now, if we just look at one of those, which is called Slack Bolt, then we can actually see that that has 15 children, okay? So 8 into 15, okay? And if we then build that out, we can see a tree, and that tree looks like this. So I couldn't show it all, so we've got the highlight on the left and the full tree on the right there, and you can see it's a big tree, okay? Remember, this is 1/8 of my tiny application, okay, with 8 dependencies. This is just one of them. There are thousands or hundreds of them. Let's just consider one of those things marked in red down the bottom there, okay? I don't use that. I don't reference it at all. I just use stuff that uses it. And unfortunately, that piece of code has been deprecated. It's no longer maintained. It shouldn't be used. But I can't do anything about that because I don't use it directly, okay? So the problem with the supply chain is I'm not in control. What about if it was vulnerable? What about if we look at that component marked in red there? Consider, again, we don't use this component directly, but we have an actual vulnerability, reported vulnerability against that piece of code. We would deploy our application, we'd have no knowledge, and we would have a vulnerability in that application, even though our code itself is not vulnerable. That's the problem of the supply chain, and that's the scope of it. Okay, you can stop being developers now. It's so stressful, I know. So the next question is, what exactly is this idea of the executive order around SBOMs? What are they? What is this purpose? Well, essentially, an SBOM is a machine-readable file that tells you what you have in your software, okay? That's all it is. But in its own right, it's going to do very little, because what it actually is it's evidence. It's like a certificate of what you've done to develop the software. And like any certificate, if the tests that you run behind it are meaningless or not very good, then the certificate isn't worth anything. So SBOM is just the evidence of the process used to develop the software in the first place. So I would like to posit that SBOM is not going to solve a problem, it's just going to evidence the fact that you might have a problem. Do you understand? In its own right, it's not helpful. And so your suppliers, you need to be asking them questions about, well, how good is your supply chain? How good are you doing? What's the different processes that you're using? Now, one other factor is, when we develop software, we've got a continuum. From on the left-hand side, we've got first-party code, which is written as pure source, usually. We're writing it. And then what we will do is we'll include dependencies, we will compile things and put them together, and we'll move across to the actual runtime environment, where it runs, okay, wherever it runs. And the point to make is that that is a transition from, essentially, source into binary. Now, clearly, there are some scripted languages which don't have binary, but anyway, we have this continuum moving from one to the other. What that means is that one approach isn't going to work. We need multiple approaches, okay? And we'll come back to that in a moment. Now, one other thing to say, and I'm just checking my timer here. One other thing to say is what does an SBOM actually have inside it? So what we've actually got is it's got its own content around the nature of what I'm distributing, but it also has this hierarchy of the things inside my software, the components and subcomponents. There are multiple formats, they don't matter, and there's something else that you need to know called VEX, or VDR, Vulnerability Exchange. And essentially the idea is that all suppliers will tell all of their customers about vulnerabilities in their software using this VEX format, okay? And that's very nice. Now, the workflow that we would have as a developer or a supplier of software is we have our third parties, open source and other vendors. We have our application, and we also have our internal libraries. And we can see here that what we have is a flow of those components to create the actual components. And we've got open source everywhere, and then we distribute that to the customer, okay? And what we need to do is we need to flow those SBOMs through. Now, for the speed, I won't talk about it, but essentially you can imagine you need to aggregate, you need to collect, you need to get that data working. Now, there's several problems with this model, okay? SBOM has lots of issues. They include the fact that it's a developing standard. Every day that goes by, the various US and EU and other organizations are coming out with new ideas in order to manage SBOM. Another thing to say is that we actually have multiple standards available, again, different file formats. There's problems with aggregation. No one actually knows what a component or a subcomponent or a package is. And there are problems with actually identifying software. And again, you don't need to know, but there's different methods of doing it, and they're not consistent. So what we actually need is a workflow to get this resolved. And the simplest workflow is to go back to this way that we build software, and actually consider those components that we're receiving from other people and validate them. And what I mean, essentially, is take their SBOM that they will be required by law to provide to you, and actually then scan it again, scan the software again using binary techniques, and you will find that there's extra components in there they didn't know about, and you will probably find that you're vulnerable to them, to various things as well. Now, the point to make is you need to look at the way that software is being developed, and there's lots of ways that you can add open source and third party. So you can have dependencies and software, hierarchies, you can have snippets of code copied from other places, you can have binaries, and you can have Docker and containers is another way. And what you need to do when you think about your supply chain is not relying on any one technique, not relying on the SBOMs that you receive, essentially doing multiple different types of scan. So multi-factor scans, looking at binaries and sources, snippets and so on. This will help you. One other point, by the way, how long have I got? I think I'm just coming up to time there. One other point is that we have this public workflow around vulnerabilities, and that really isn't fit for purpose. So this vulnerability workflow that you hear from other vendors, the problem is that it takes a long time to know about vulnerabilities. They're very slow, very difficult to know about, and they have poor information in them. So you need a secondary or a proprietary way of knowing about vulnerabilities, and this is software vulnerabilities. And that essentially is a secondary workflow to look at things like social media, look at exploits as they happen, and tell you about things that are not public, because the public disclosure is slow. So in summary, and I'm going to get to the conclusion here, really what we need to do is we need to think about the fact that we can't rely on SBOMs as a solution. We need to be able to scan the applications that we're receiving as we're either developing them or as we're receiving them from our suppliers using multi-factors. We need to use advanced vulnerability data. We can't rely on the public workflow, on the public data there. Something else is that we need to think of security as everywhere. Thinking that it's just a developer problem or it's just a supplier problem or whatever is not correct. It's everybody's problem. So everybody is responsible for security. We can't just say it's someone else's issue. And then finally, thinking about SBOM, we need to recognize that it's more of a challenge than it is a solution, and that we need proper technology and processes in order to support SBOMs. So great. Thank you very much for listening. I hope that was interesting. If you'd like to talk to us, then we're outside. So thank you very much.
Matthew, brilliant.
Thank you.